Hello, I'd like to introduce you to the Scanning Electron Microscope, the SEM. The electron microscope uses not visible light, but an electron beam to scan a specimen and allow us to observe its surface. At the top of the electron microscope column, there is an electron gun where the electron beam is produced. There are various types of electron guns, and most KOSEM products use the type that have thermionic filaments. This tungsten filament has a drawback. It has a comparatively short lifetime of between 40 hours and 100 hours, depending on the operating conditions and settings. But the great advantage of a tungsten filament is that it can be used in a low vacuum and is less expensive and replaceable by any operator, helping to keep its maintenance cost at a relatively low level. The electron beam generated by the electron gun passes through a condenser lens, apertures, and an objective lens, and then reaches the specimen. The two condenser lenses reduce the size of the electron beam by condensing it, and the objective lens is used to focus the condensed electron beam into the accurate point that needs to be observed on the surface of a sample. When the electron beam finally hits the specimen, various signals are produced, and these signals are collected by a detector of the electron microscope to produce images of the specimen. To begin with, secondary electrons can be detected by the SE detector to allow observation of the basic shape and surface topography of the specimen. After passing through the detector, the secondary electrons collected are transformed into optical signals, which will then be amplified and transformed into electric signals. Depending on the quantity and brightness of these signals, the image may be displayed on the monitor in black, white, or gray levels. Thus, all images produced by the electron microscope are black and white, and colors can be added to the images afterwards using the imaging program. In addition, the BSC detector collects backscattered electrons to provide information on the morphology of the specimen. Meanwhile, EDS is an elemental analysis tool that uses characteristic X-rays to reveal the composition of a sample. EDS is particularly useful for discovering the composition of a certain point of the specimen quickly and easily, while observing it through an electron microscope. The lifetime of a filament is between 40 hours and 100 hours, depending on the operating conditions. As such, a filament may break after being used for a certain period of time, and an operator is expected to replace the filament and adjust the alignment in person. As a measuring instrument is sensitive to contamination, an operator needs to wear disposable latex gloves while working on the replacement. 1. Convert the pump mode to the vent mode. 2. Take the upper cover off the equipment to replace a cartridge. 3. Once the equipment is completely vented, hold the electron gun and lift it forward as demonstrated in the video. 4. You may see the clamp ring and cartridge in the electron gun. Release the clamp ring manually and remove the cartridge from the electron gun using an extractor. Be sure to place the parts of the measuring instrument in an uncontaminated spot. 5. Fit the new cartridge into the hole and push it in until it reaches the same height as the one demonstrated in the video. 6. Tighten the clamp ring again until it returns to its initial condition and fit the electron gun closely onto the column. Make sure to cover it with the properly inserted O-ring. 7. Complete the replacement by converting the vent mode to pump mode. KOSEM's CP8000 is a cross-section polisher that prepares a sample by etching its cross-section using argon plasma. Unlike the existing polishing methods, the CP8000 utilizes argon plasma, not sandpaper or human hands, enabling it to obtain a clear cross-section without compromising the sample at the time of etching. Moreover, the basic etching process, including polishing, etching, and cleaning, can be simplified to one-time polishing, which can still provide a clear cross-section. Our CP8000 allows clear observation of nano and microscale areas inside the sample. At the same time, large area polishing can also be done with the CP8000, which, through its swinging stage, makes possible the observation of a few hundred micro-thick areas within 1 hour. As for the application, the CP8000 can be used to view inside a nano-sized particle to observe its internal structure, as well as to view a nanowire, nanofiber, or a stacked semiconductor device. In addition, the CP8000 can provide support for the preparation of metal and ceramic materials by polishing them for a subsequent analysis of their internal structure images and EBSD data, so as to allow the observation of grains from these types of samples. The electron microscope products of KOSEM are mainly divided into two types. First, the product you see here is the KOSEM tabletop electron microscope that's convenient when dealing with limited installation space or for those operators who don't need to observe samples at high magnification. The LED bar in front shows the level of the vacuum inside the chamber. The electron microscope can be operated by turning on the electron gun when this LED bar is fully lit. The small button under the LED bar can be used to turn on or off the vacuum. However, as this is an emergency button, it is recommended to control the vacuum via software. The power button is on the right side of the bottom of the microscope. Remember to always make sure that the microscope is in vacuum state before you turn it off. Above the power button is an aperture that can be manually adjusted. Perforated with micron scale holes, the aperture can be used to directly adjust the size of the electron beam, helping an operator find optimal conditions for the observation of each specimen. The instructions on how to adjust the aperture will be provided in detail in another video clip. On the back side of the product, there are various signal lines such as a power cord and pumping hose. Let's disassemble the cover of the electron gun at the top. This part is the electron gun, and an operator can easily replace the tungsten filament by opening this part when needed. Now, let's open the chamber in vent mode with the vacuum turned off to take a look at what the specimen stage looks like. The stage of this tabletop SEM moves along motorized X, Y, and T axes. You can adjust the height of the Z axis manually as needed after checking its maximum height using the ruler that comes with the product. The second type of product is the floor standing type electron microscope of KOSEM. It has a greater maximum magnification than the tabletop model and allows analysis of a bigger specimen. As in the tabletop model, the electron gun is located at the top of the electron microscope. The shape of the electron gun and its replacement method is the same as that of the tabletop model. Let's open the chamber and take a look at the stage. This product is equipped with 5 motorized axes, the fully automatic X, Y, R, T, and Z axis systems. This product also offers an auto-stitching function that scans different parts of the specimen surface continuously and stitches them together automatically, enabling the analysis of a large surface area. For more detailed specifications of the products, please refer to the company website below. Gun alignment refers to the procedure that is taken to ensure that the electron beam passes through the very center of CL and the ribbon aperture holes by aligning the root of the electron beam from its origin at the electron gun to the sample in a straight line. This procedure is an essential part of ensuring the initial performance of the equipment, as the performance of the microscope may not reach the expected level if the alignment is not properly carried out. Basically, gun alignment refers to the process of finding the brightest spot. The more beams pass through holes in a straight line, the brighter image you can get even in low contrast conditions. 1. Turn on the electron gun. Two, set conditional values as follows before starting the gun alignment. Set ACC voltage to 20 kV. Set spot size to 16. For NS gun alignment, click the center button on the software. Image mode. Reduce. An image mode with the fastest response time is used to find the brightest spot. Three, once the preparation is done, start the gun alignment by adjusting the set screws of the electron gun using both hands. 4. Release each of the 4 set screws half around to allow the electron gun to move freely to maintain its balance. This adjustment needs to be carried out about 3 times, not just once, by turning each screw in a different direction so as to find the focal point. The moment you find the focal point, tighten all 4 set screws in order to prevent the electron gun from being moved slightly by any potential vibration or physical factors. You need to keep your eye on the brightness of the monitor while tightening the screws, as the gun could be moved from the central position in this process. Once you complete the manual alignment, check whether the gun is accurately aligned using the gun alignment program of the software. The alignment is done accurately if the monitor gets darker, not brighter, when you move the x-axis or y-axis to the left or right. However, in case there is any brighter spot found in this process, you can use the electron gun as it is if the spot is within the scope of the red dots. But if it goes out of the scope, you need to repeat the manual gun alignment process from the beginning.